Okay, a quick revision. So chapter 6, okay, functions is the first thing. What's a function? Being able to recognize a function when you see one. So a function is a rule that produces one output value only for each input. So as in for every x there's one y. For every x there's one y. Okay? Y can have as many x's as you want, but for every x there must be one and only one y. Right, how do you recognize a function? Right, from a mapping diagram, right, okay, there's exactly one arrow leaving the input. So it doesn't matter where the arrows are going, so it doesn't matter that two arrows go to the one spot, nothing comes to this spot, right, okay, it doesn't matter where the arrows go, right, as long as there's exactly one arrow leaving everything here. So this one, the first one is a function, this one is not a function, because there's two arrows leaving the first point. Okay, so this is not a function. Another reason for it not to be a function would be if there was a point there with no arrow leaving it. Okay, so there has to be exactly one arrow leaving for it to be a function. So the first one is a function, second one is not a function. How do you recognize a function from a list? Okay, so to recognize a function from a list, you just look at the first numbers and make sure the first numbers, the inputs, the x's are not repeated. So you look at 0, 1, 2, 3. There's no repeated number there, so the first one is a function, right? This one is not a function because 0 is there twice. So you don't need to look at the second numbers, just the first number. Here we have 0, 0, 1, 3. 0 is there twice, so that means it's not a function, right? And then how do you decide whether something is a function from a graph? You do what's called the vertical line test. And you draw a vertical line anywhere on the graph, right? And if the vertical line hits the graph exactly once, so it must hit it exactly once. So that means it has to hit it at least once, but it also has to hit it at most once, right? So this one here, right, okay, you probably can't see what it was now, but this is a function. Right, because if you draw a vertical line, you'll hit the graph exactly once. Any vertical line in any position. Okay, whereas this one, this circle down here, is not a function. And the reason that's not a function is because if you draw a vertical line, it's going to hit it twice. If you draw a vertical line, it's going to hit it twice. Okay, so that means it's not a function. Okay, so that's recognizing a function from a mapping diagram, from a list, and from a graph. Okay, then the domain and the range, guys. The domain is all the input values, all the x's, right, or everything in the first circle, right, for a mapping diagram, right. So if you list out these are all the inputs, right. Okay, and the range, guys, is all the output values. Okay. Remember, I'm just revising this now, so if you need more, you need to go back to the original videos, right? Here's an example. So g of x is x plus 5, f of x equals x squared minus 1, find f of minus 3. That means instead of an x, into f, put in a minus 3. So f is this one, so instead of that x, I'm putting in a minus 3, so that's minus 3 squared minus 1 into the calculator with that, right? Okay, that will give you 8. Okay, g of 3 means into g, put 3 in instead of x. So the into g is here, so instead of that x, I'm writing a 3. So it's 3 plus 5. 3 plus 5 is 8. Right? F of k means into f, everywhere I see an x, put in a k. So you're just writing the letter k instead of the letter x. So it's k squared plus 1. And g of k plus 1 means into g, everywhere I see an x, I'm putting in a k plus 1. So it's k plus 1, x plus 5. So instead of x, I'm writing k plus 1. Right? And then I can simplify that. That's actually k plus 6. Okay? Now, find the values, right, for which of x where g of x equals 7. Okay, so this time I'm not telling you what to put in, right? Because if I was telling you what to put in, it would be written inside in the bracket. So I'm not telling you what to put in, I'm telling you what you got out. So into G, I'm telling you, you put something for X and the answer you got was 7. So you filled in X and the answer you got was 7. So you just write down the function and you let it equal to 7. X is on one side, numbers on the other. So leave the X, leave the 7, bring over the plus 5 becomes minus 5, and you get X is equal to 2. Right, this one, girls, f g of 2. That reads f after g of 2. So it means f after g means you do g first. So I get g of 2 first. So back up and see what g was. G is x plus 5. So in there, everywhere I see an x, I'm putting in a 5. 2 plus 5. So my answer is 7. I then take my answer and put it into f. Right? So you take the answer, which was 7, and stick it into f. So into f, everywhere I see an x, put in a 7. So it's 7 squared minus 1, and that works out to be 48. Okay? G after f of 2, right? So that means you do G after f, so this time we do f of 2 first. So into f, everywhere I see an x, put in a 2. So it's 2 squared minus 1, which is 3. You then take your answer from the first part and you put it into g. So now I want to get g of 3. And g was x plus 5. So that means instead of that x, I'm writing in a 3. So 3 plus 5, which is 8. Okay, and then the last one I wanted to do was fg of x, right? So that means you just do g of x first. So you're not putting in a number, you're just putting in a letter. So g of x is x plus 5, right? Then you have to put x plus 5 into f. So into f, everywhere I see an x, I'm putting an x plus 5. So f was x squared, so it's x squared minus 1. Okay, you then need to multiply that out to simplify it. Okay, so this is going back to your algebra. X plus 5 to be squared means x plus 5 multiplied by x plus 5. And then there's a minus 1 at the end, right? Split up the first bracket, write the second bracket down twice, is how we multiply out brackets. Plus 5, bracket x plus 5 minus 1. That's x squared plus 5x plus 5x plus 5 5s are 25. And then there's a minus 1 at the end. So tidying that up, we'll get x squared. 5x and 5x makes 10x. And 25 minus 1 is plus 24. And that's my answer. Okay? The last section in this chapter was finding unknown coefficients. So you're given the equation, right, okay, of the function, but there's a bit missing. As in this case, there's a number in front of the x and we don't know what it is, right? And we have to find out what it is. Okay, so they give you a point. So everywhere I see an x, put in a 1. Everywhere I see a y, put in a 5. So in that, instead of that y, put in a 5. Instead of that x, put in a 1. Okay, how do I know to do that? Because they told me a point. So that means they've told me what x is, they've told me what y is. Then multiply out, so you get 5 is equal to k plus 4. K is on one side, numbers on the other. So bring the k over, becomes a minus k. The 4 stays over here and the 5 comes over and becomes a minus 5. So that means minus k equals minus 1. So change the sign, k is equal to plus 1. A second example. Right, if 1, 2 is on the curve here, right, okay, again, we're missing the p, so we're missing what that number is, okay. Remember, g of x curves is another way of saying y. So So that's actually, excuse me, that's equal, y equals x squared minus 2x plus p. So everywhere I see an x, I'm putting in a 1. Everywhere I see a y, I'm putting in a 2. So everywhere I see an x, I'm putting in a 1, y is 2. So that's 1p squared minus 2 times 1 plus p. Multiply out, 2 is equal to 1 squared is 1, 2 times 1 is 2, plus p. Then I put the p on one side, the numbers on the other. So bring the p over, it becomes a minus p, right? Here, the 1 minus 2 are this side already. This minus 2 comes over and becomes a minus 2. So you get minus p is equal to, become minus 3. And then if minus p is equal to minus 3, that means plus p is equal to 3. Okay? And that's all we have from chapter 6.